In the 1970s, both the French Air Force and Navy were looking for a new fighter that would replace older models such as the Jaguar, Mirage F1, F-8 Crusader and the Super Étendard, and that would initially complement and later replace the Mirage 2000. This new fighter, which alone would take the place of air superiority, ground attack and naval attack aircraft, would need to be fully multi-role, breaking with the tradition of specialized aircraft. In the search for this new fighter, the French even participated, along with other countries such as the United Kingdom and Italy, in the joint program that would later give rise to the Eurofighter Typhoon, but some differences in requirements and other disagreements led France to abandon the program, having been forced to develop this new aircraft model alone as well as most of its components, and thus the Rafale was born. The Rafale is a twin-engine Delta Canard. It is powered by two Snecma M88 engines. Each of these engines generates anywhere from 16 to just over 20,000 pounds of maximum afterburn power, depending on the version. This engine gives the Rafale a good power-to-weight ratio, being able to take it to a maximum speed of Mach 1.8. It is also capable of taking the French fighter in a supercruise regime, that is, at supersonic speed without the use of afterburners, at a speed of up to Mach 1.4 in an air combat configuration with 4 missiles. The climb rate is another Rafale differentiator. While other dual-engine fighters like the F-15 and Sukhoi Su-35 have climb rates of 250 and 280 meters per second, respectively, the Rafale has a climb rate of approximately 300 meters per second, which added to the flight in a supercruise makes it a good interceptor. However, the Rafale's biggest differentiator is not its flight performance, although it doesn't disappoint in that respect, but its electronic suite. As the main sensor, the Rafale uses the RBE-2 radar with AESA technology. The difference between an AESA radar and a regular radar is mainly in the antenna. While a traditional mechanically scanned radar uses a single antenna that emits and receives signals, the AESA radar is made up of hundreds or thousands of transceiver modules, which are like small radars that can function independently. These transceiver modules emit their signals electronically and independently of each other, which gives AESA radars the ability to scan airspace at a much higher speed, the ability to operate in air-to-air and air-to-ground modes simultaneously, greater resistance to electronic interference, plus a lower probability of being detected by enemy radar warning systems. The Rafale's RBE-2 AESA radar has 838 transmitter modules, and its actual range, although classified, is estimated to be between 150 to 200 kilometers against targets such as fourth-generation fighters. To complement the radar, the Rafale is equipped with the OSF electro-optical system. It consists of an infrared tracking system, a TV camera to identify targets and a laser rangefinder to measure distances. The infrared tracking system that originally equipped the Rafale was withdrawn due to operational problems, but remained with the TV channel for visual identification of targets at long distances. Under ideal conditions, the Rafale's OSF system TV channel is estimated to be able to identify a target at distances greater than 50 kilometers, which is a very important capability, as rules of engagement may require visual identification before launching a missile. This skill is also important in ground attack missions. The Rafale, however, should once again receive a dedicated IRST system in its future updates. Another very important system that helps the Rafale to detect and identify its potential targets, be they air, land and naval, is the ESM capability. ESM stands for Electronic Support Measures. In the Rafale, the ESM capability consists of a radar alert receiver and a signal library capable of storing detected signals for later identification. It has 4 radar alert receivers, 2 on the edges of the air intakes, and 2 on top of the vertical stabilizer, ensuring 360-degree coverage. AESA radar can also serve as a highly sensitive radar warning system. These receivers are capable of detecting emissions from enemy radars in a wide range of frequencies, from 2 to 40 GHz, which includes from long-range radars operating in the S-band, to millimeter-wave radars used in short-range anti-aircraft systems and anti-aircraft missile search heads. This system has interferometric technology, which informs the direction of emission of an enemy radar with an accuracy of less than 1 degree. Although the distance cannot be informed automatically, as it is a passive sensor, it can be established through a triangulation between two or more Rafales. The signal library complements the radar warning system. Each time the Rafale detects a radar signal, this signal is stored and all its parameters are analyzed. If it detects that signal again, it will know exactly what type of radar it is detecting. The Rafale's ESM capability, comprising the radar warning system and signal library, is complemented by the ECM capability. ECM are the electronic countermeasures. It is the ECM systems that are responsible for effectively interfering with a radar, to degrade its performance or simply generate a false target. The Rafale has 3 ECM AESA antennas that cover 360 degrees, located one at the base of each canard and one at the rear-facing lower vertical stabilizer base. These antennas can interfere with land-based radars, naval radars, air radars and even anti-aircraft missile search radars. For self-protection, the Rafale also has a missile approach warning system. This system, mounted on the sides of the vertical stabilizer, is spherical, and covers almost all directions, with a small exception that is covered by the structure of the aircraft itself, as can be seen at the bottom of this image. This system detects the approach of an enemy missile through the heat generated by the combustion of the engine or simply by its friction with the air. Once a missile is detected, the system informs the pilot of the approach direction as well as automatically releasing expendable countermeasures to try to evade that missile. The Rafale also has a laser alert system, which alerts the pilot when a laser, such as those used to measure distances or guide missiles, is aimed at the aircraft. All of these radar, approach missile and laser warning systems, as well as electronic jamming systems, are part of the Spectra electronic warfare suite, considered one of the most advanced in the world. The Rafale's cockpit is also very modern. The control panel has 3 multifunctional screens that display all information about the aircraft and combat system. Further up is the HUD, reporting other general flight and combat data. The pilot also has a helmet with an integrated sight, which allows, among other things, to fire missiles just looking at the target, without necessarily having to point the nose of the aircraft in its direction. The Rafale has a total of 14 hardpoints for transporting weapons and external tanks, and can carry a total of up to 9.5 tons of external cargo. Among the main weapons carried by the Rafale is the Meteor missile for long-range aerial combat. This missile has a ramjet-type propulsion, and is guided by active radar, and can supposedly hit air targets over 200 kilometers away. He can also use the Mica missile. This missile can be used in short and medium-range combat, and has 2 search heads, one for active radar and the other for infrared. To attack surface targets, the Rafale can use the Apache cruise missile. The Apache is a missile specifically designed to attack runways and take off, putting air bases out of operation. The range of this missile is about 150 kilometers. Another cruise missile that can be used is the Scalp, for example. The Scalp EG is a general-purpose cruise missile, with a range of approximately 560 kilometers for the domestic versions. The Rafale can also use AASM missiles, which is basically a kit, consisting of a GPS, infrared or laser guidance system, in addition to a rocket engine, which transforms dumb bombs into guided missiles. The range can reach 50 kilometers. The Paveway series laser-guided bombs can also be used by the Rafale. To attack naval targets, the Rafale's main weapon is the AM-39 Exocet anti-ship missile. This missile, which is the most modern version of the missile that the Argentines used with great success in the Falklands War, having sunk several British ships, is guided by active radar and has a range of approximately 70 kilometers. The Rafale also uses, for domestic use only, a supersonic missile for nuclear attack, with a range of approximately 500 kilometers. As internal armament, a 30mm cannon is carried, with a rate of up to 2,500 rounds per minute. The Rafale has enjoyed considerable success in the export market. It has already been acquired by Croatia, Egypt, Greece, India, Indonesia, Qatar, the United Arab Emirates, in addition to France itself. It's an expensive plane, and its unit value in export contracts has easily exceeded $200 million, which should indicate that it really is a great product, as it continues to sell a lot even at this high price. It is a legitimate multi-role fighter, capable of performing the most diverse missions with great efficiency. Thanks for watching this video, subscribe to the channel, and see you next time.